problem. Limit x tends to infinity, right? Limit x tends to infinity. You have e to the power x over x squared. Okay, right. So let's see how to solve this problem, right? So now if you directly apply infinity, what you will be getting is e to the power infinity. E to the power infinity will be infinity. Infinity squared will be infinity. So it is something like infinity divided by infinity, which is an indeterminate, right? So you cannot continue in this format, right? So according to the L'Hopital rule, what you can do, you can differentiate the numerator. What is, if you differentiate numerator, limit x tends to infinity, d by dx of e to the power x, d by dx of x squared, right? So limit x tends to infinity, answer is e to the power x divided by 2x. Okay, right. Okay, so now let's try to apply x tends to infinity. So in this case also, e to the power infinity is infinity, twice infinity is also infinity, infinity divided by infinity, so again you are getting indeterminate, right? So it doesn't matter, you can differentiate for the second time also, right? Right, or in other case that you can get the second derivative of that, because that is something like you have to go on checking, right? First time you differentiated, then you try to apply x tends to infinity, so again you are getting an indeterminate, right? So now what you can do is again you can differentiate this. So I will be going there, limit x tends to infinity, again d by dx of e to the power x, d by dx of 2x, no problem. So now let's see what is the answer. Limit x tends to infinity, d by dx of e to the power x is e to the power x, 2x means it's 2. So now let's try to apply e to the power infinity divided by 2. E to the power infinity is infinity, infinity divided by 2 is infinity. So now you got an answer for that, right? So that is also done.